NEC Section 314.28 ATWO addresses the requirements for calculating the minimum dimensions of pole boxes, junction boxes, and conduit bodies. This section is crucial for ensuring proper space for conductors within these enclosures, especially when dealing with angle or U-poles. The rule states that for angle poles or U-poles, the distance between each raceway entry inside the box and the opposite wall of the box must not be less than 6 times the trade diameter of the largest raceway in a row or column. This requirement is further increased by the sum of the diameters of all other raceway entries in the same row on the same wall of the box. To break this down, firstly, identify the largest raceway entering the box on a given wall. Multiply the trade diameter of that largest raceway by 6. This gives you a base dimension. Secondly, identify any other raceways entering the box on the same wall and in the same row as the largest raceway you identified previously. Thirdly, determine the trade diameters of each of these additional raceways. Add these diameters together. This gives you the additional length required due to these additional raceways. Finally, add the result of step 1, that is 6 times the largest raceway, to the result of step 3, the sum of the other raceways' diameters. This gives you the minimum required dimension of the box in that direction. Let's illustrate this with an example. Consider a pole box with two 2-inch raceways entering on the same wall and in the same row. The largest raceway is 2 inches. 6 times the largest raceway is 6 multiplied by 2 inches, which equals 12 inches. The other raceway on the same wall is also 2 inches. The sum of the diameters of the other raceways is just 2 inches in this case. The minimum required dimension of the box is 12 inches plus 2 inches, which equals 14 inches. Therefore, the box must be at least 14 inches long to comply with NEC Section 314.28 ATWO. It's important to note that this calculation provides the minimum dimension. In practical applications, it may be necessary to increase the box size to accommodate conductor bending radii splices or other equipment within the box. Always refer to the specific requirements of NEC Section 314.28 and consult with a qualified electrical inspector to ensure compliance with all applicable codes and standards. The NEC specifies these requirements to ensure that conductors are not damaged during installation or pulling, and that there is sufficient space for heat dissipation and maintenance. Failure to comply with these requirements can lead to overheating, insulation damage, and potentially hazardous conditions. Understanding these rules is essential for electrical contractors, engineers, and inspectors to ensure safer and compliant electrical installations. Proper box sizing is not just a matter of code compliance. It also affects the long-term reliability and safety of the electrical system. Overcrowded boxes can lead to conductor damage and increased risk of electrical faults. Sufficient space within the box allows for proper conductor bending radii, reducing stress on the insulation and connections. This contributes to a more robust and reliable electrical system. Furthermore, adequate box size facilitates ease of maintenance and troubleshooting. When conductors are properly organized and spaced within the box, it is easier to identify and address any issues that may arise over time. This can save time and money in the long run and reduce the risk of electrical hazards during maintenance activities. In summary, NEC Section 314.28 ATWO provides a clear and straightforward method for calculating the minimum dimensions of pole boxes and junction boxes. By following these requirements, electrical professionals can ensure safe, compliant, and reliable electrical installations. Always remember to consider all factors, including conductor size, raceway size, and the presence of any splices or equipment within the box when determining the appropriate box size for a given application. Adherence to these standards not only ensures code compliance but also contributes to the overall safety and longevity of the electrical system. Additionally, remember to check local amendments and interpretations of the NEC, as these can sometimes vary from jurisdiction to jurisdiction. Always consult with local authorities having jurisdiction, OJ, for clarification on any specific requirements or interpretations. The NEC is a comprehensive document, and it is important to stay up to date with the latest revisions and interpretations. Regular training and continuing education are essential for electrical professionals to maintain their knowledge and skills in this rapidly evolving field. By staying informed and following best practices, you can ensure that your electrical installations are safe, compliant, and reliable for years to come. Let's delve deeper into the practical implications of this rule. Imagine a scenario where you are installing a new electrical service for a commercial building. The service requires multiple large conductors to be pulled through a series of pull boxes. If you underestimate the size of the pull boxes, you could encounter several problems. Firstly, you may find it difficult or impossible to physically pull the conductors through the boxes. The conductors may bind or snag on the edges of the raceways, making it difficult to achieve the required pulling tension. This can lead to damaged conductors and increased installation time. Secondly, even if you are able to pull the conductors through the undersized boxes, you may be violating the NEC requirements for conductor bending radii. The conductors must be bent smoothly within the box, without exceeding the minimum bending radius specified in the code. If the box is too small, you may be forced to bend the conductors too sharply, which can damage the insulation and reduce the current carrying capacity of the conductors. Thirdly, undersized pull boxes can create excessive heat buildup within the box. The conductors generate heat as they carry current, and this heat must be dissipated effectively to prevent overheating. If the box is too small, there may not be enough air circulation to dissipate the heat, leading to elevated temperatures within the box. This can accelerate the degradation of the insulation and increase the risk of electrical faults. To avoid these problems, it is essential to carefully calculate the required pull box size before beginning the installation. Consider all factors, including the number and size of conductors, the size and type of raceways, and the presence of any splices or equipment within the box. Use the NEC guidelines and consult with a qualified electrical engineer or inspector to ensure that you are selecting the correct box size for the application. In addition to the NEC requirements, it is also important to consider the practical aspects of working with large conductors. Large conductors can be heavy and difficult to handle, especially in tight spaces. Make sure to provide adequate support for the conductors during installation and use appropriate tools and techniques to avoid damaging the conductors. Also, consider the accessibility of the pull boxes for future maintenance and troubleshooting. Locate the boxes in areas where they can be easily accessed and inspected, and provide adequate clearance around the boxes for working space. This will make it easier to perform maintenance and repairs in the future and reduce the risk of electrical hazards. Remember that proper pull box sizing is not just a matter of code compliance, it is also a matter of safety and reliability. By following the NEC guidelines and using good engineering practices, you can ensure that your electrical installations are safe, compliant, and reliable for many years to come. Let's further explore the nuances of applying Section 314.28 at WO in various scenarios. Consider a situation where you have multiple raceways of different sizes entering a pull box on the same wall. For instance, you might have one 4-inch raceway, one 2-inch raceway, and two 1-inch raceways all entering the same wall. In this case, the largest raceway is the 4-inch raceway, so you would start by multiplying 4 inches by 6, which equals 24 inches. Then, you would add the diameters of all the other raceways on the same wall. This would be 2 inches plus 1 inch plus 1 inch, which equals 4 inches. Finally, you would add 24 inches and 4 inches to get a minimum box dimension of 28 inches. Now, let's consider a situation where the raceways are not all in the same row on the wall. The requirement in 314.28 at WO specifically refers to raceways in the same row. If the raceways are staggered or offset, you need to consider them separately. You would calculate the minimum box dimension for each row of raceways and then use the largest of these dimensions as the minimum box dimension for that wall. It's also important to remember that this rule applies to both angle pulls and U-pulls. An angle pull is where the conductors enter the box on one wall and exit on a different wall at an angle. A U-pull is where the conductors enter and exit the box on the same wall, making a U-shaped bend inside the box. The NEC requires the same minimum box dimensions for both types of poles to ensure that the conductors are not bent too sharply. Another important consideration is the type of raceway being used. The rule refers to the trade diameter of the raceway. The trade diameter is the nominal size of the raceway, not the actual outside diameter. For example, a 2-inch rigid metal conduit, RMC, has a trade diameter of 2 inches, but its actual outside diameter is slightly larger. Always use the trade diameter when calculating the minimum box dimension. In addition to the raceway entries, you also need to consider the conductor bending space within the box. The conductors must have enough space to be bent smoothly without exceeding the minimum bending radius specified in the NEC. The bending radius depends on the size and type of conductor. Larger conductors require larger bending radii. Make sure to account for the conductor bending space when selecting the appropriate box size. Furthermore, consider the presence of any splices or terminations within the box. Splices and terminations take up space and can affect the conductor bending space. If you have a lot of splices or terminations, you may need to increase the box size to accommodate them. Also, consider the type of connectors being used. Some connectors are larger than others and may require more space within the box. Finally, remember to consult with the local authority having jurisdiction, OJ, for any specific requirements or interpretations of the NEC. The AHJ has the final say on whether an installation complies with the code. It's always a good idea to get the input before beginning the installation to avoid any potential problems. In conclusion, calculating the minimum box size for angle poles and U-poles requires careful consideration of several factors. The NEC section 314.28 ATWO provides a clear and straightforward method for determining the minimum dimensions. By following these guidelines and considering the practical aspects of working with conductors, you can ensure that your electrical installations are safe, compliant, and reliable. Always remember to consult with qualified professionals and the local AHJ to ensure that you are meeting all applicable requirements. Let's explore some specific examples to further clarify the application of NEC section 314.28 ATWO. Example 1. A pole box has one 3-inch conduit and two 1-inch conduits entering the same wall in the same row. The largest conduit is the 3-inch conduit. Therefore, we multiply 3 inches by 6, which equals 18 inches. Then, we add the diameters of the other conduits, which are 1 inch plus 1 inch, which equals 2 inches. Finally, we add 18 inches and 2 inches to get a minimum box dimension of 20 inches. Example 2. A pole box has one 4-inch conduit and three 2-inch conduits entering the same wall in the same row. The largest conduit is the 4-inch conduit. Therefore, we multiply 4 inches by 6, which equals 24 inches. Then, we add the diameters of the other conduits, which are 2 inches plus 2 inches plus 2 inches, which equals 6 inches. Finally, we add 24 inches and 6 inches to get a minimum box dimension of 30 inches. Example 3. A pole box has two 3-inch conduits and one 2-inch conduit entering the same wall in the same row. The largest conduit is the 3-inch conduit. Therefore, we multiply 3 inches by 6, which equals 18 inches. Then, we add the diameters of the other conduit, which are 3 inches plus 2 inches, which equals 5 inches. Finally, we add 18 inches and 5 inches to get a minimum box dimension of 23 inches. Example 4. A pole box has one 2-inch conduit and four 1-inch conduits entering the same wall in the same row. The largest conduit is the 2-inch conduit. Therefore, we multiply 2 inches by 6, which equals 12 inches. Then, we add the diameters of the other conduits, which are 1 inch plus 1 inch plus 1 inch plus 1 inch, which equals 4 inches. Finally, we add 12 inches and 4 inches to get a minimum box dimension of 16 inches. These examples illustrate how to apply the rule in different scenarios with varying conduit sizes and quantities. Remember to always identify the largest conduit first and then add the diameters of all the other conduits in the same row on the same wall. The result is the minimum required dimension of the box. It's also important to consider the other requirements of NEC section 314.28, such as the minimum depth of the box and the requirements for conductor bending space. These requirements may further increase the required box size. Always consult the NEC and with a qualified electrical professional to ensure that your installations are safe and compliant. Now, let's discuss some common mistakes to avoid when applying NEC section 314.28 atware. One common mistake is to forget to add the diameters of all the other conduits in the same row on the same wall. Some people only calculate 6 times the largest conduit and neglect to add the additional space for the other conduits. This can result in an undersized box and a violation of the NEC. Another common mistake is to use the outside diameter of the conduit instead of the trade diameter. The NEC specifies that the trade diameter should be used for these calculations. The trade diameter is the nominal size of the conduit, while the outside diameter is the actual physical measurement of the conduit. Always use the trade diameter to ensure accurate calculations. Another mistake is to not consider the conductor bending space within the box. The conductors must have enough space to be bent smoothly without exceeding the minimum bending radius specified in the NEC. The bending radius depends on the size and type of conductor. Make sure to account for the conductor bending space when selecting the appropriate box size. Finally, it's important to avoid guessing or estimating the box size. Always perform the calculations according to NEC section 314.28 atware to ensure that the box is sized correctly. Guessing can lead to undersized boxes and potential safety hazards. By avoiding these common mistakes, you can ensure that your installations comply with the NEC and are safe and reliable. Remember to always consult the NEC and with a qualified electrical professional if you have any questions or concerns. Let's consider a more complex scenario. Suppose you have a pull box with the following conduit entries on the top wall. You have one 3-inch conduit and one 1-inch conduit in the same row. On the bottom wall, directly opposite the top wall, you have one 4-inch conduit. On the left wall, you have one 2-inch conduit. On the right wall, you have no conduit entries. To determine the minimum dimensions of the box, you need to consider each wall separately. For the top wall, the largest conduit is the 3-inch conduit. Therefore, you multiply 3 inches by 6, which equals 18 inches. Then, you add the diameter of the other conduit, which is 1 inch. This gives you a minimum dimension of 19 inches for the distance between the top wall and the bottom wall. For the bottom wall, you have only one 4-inch conduit. Therefore, you multiply 4 inches by 6, which equals 24 inches. This gives you a minimum dimension of 24 inches for the distance between the bottom wall and the top wall. Since the dimension from the bottom wall is larger than the dimension from the top wall, you would use 24 inches as the minimum distance between the top and bottom walls. For the left wall, you have one 2-inch conduit. Assuming the opposite wall has no conduits and is being used for the pull, you would multiply 2 inches by 6, which equals 12 inches. This gives you a minimum dimension of 12 inches for the distance between the left wall and the right wall. Since the right wall has no conduit entries, you don't need to perform any calculations for that wall. Therefore, the minimum dimensions of the box would be 24 inches between the top and bottom walls and 12 inches between the left and right walls. This example illustrates how to apply the rule when you have conduit entries on multiple walls of the box. Remember to consider each wall separately and use the largest dimension for each pair of opposite walls. Also, keep in mind the other requirements of NEC section 314.28 such as the minimum depth of the box and the requirements for conductor bending space. These requirements may further increase the required box size.